Okay, let's unpack this. Today we're doing a deep dive on, well, a single piece of hardware with a name that's a bit of a mouthful.
It is a technical one for sure.
The PureLink VIP-T300-E-RACK2 4K HDMI and USB-KM over IP encoder. So our mission is simple, really. Figure out
Sure.
how this one box becomes, the backbone for these huge professional AV systems.
Right. And at its core, the concept is pretty clear. You can think of it like a specialized translator. It takes your standard high-res video and control signal.
Follow your sources.
Exactly. It takes all that. We're talking Ultra HD 4K video, audio, RS-232, USB, and it turns it all into data packets that can travel across a normal IT network, all through a standard 1 gigabit port.
Well, what jumped out at me immediately was the flexibility. I mean, sure, it can do a simple point-to-point extension.
Yeah, that's the basic use case.
Running a signal, say, 300 meters across a building with a network switch. But that's not the real hook, is it? It's the scale.
The scale is absolutely the defining feature here. This isn't for a small office. This architecture lets designers create these massive matrix switching setups with up to 999 sources.
Okay, almost 1,000 sources.
And an almost unbelievable 65,000 displays.
Wait. 65,000 displays? And you're telling me this is all running over a typical 1 gig Ethernet port? I mean, that sounds like a recipe for some serious lag.
It would be, but that's where the engineering becomes so crucial. The spec on this is less than 17 milliseconds of latency.
Less than 17.
Yeah. And just to give you some context, anything above, say, 30 milliseconds starts to feel sluggish to a user. That sub-17 number mean even when you're switching on a huge scale, it feels instantaneous. That's critical for, live monitoring or KVM applications.
Right, and KVM, for anyone listening, is keyboard, video, and mouse letting you control a computer remotely like it's right there. So if the speed is covered, what about the quality? How clean is the data that's actually moving? It supports 4K UHD 4.4.4 at 30 hertz. What's the thinking behind prioritizing that 4.4.4 color?
That's a key decision. 4.4.4 means you get perfect zero-loss color fidelity. There's no subsampling. So while you're capped at 30 frames per second for 4K, you get absolutely perfect color, which is non-negotiable for medical imaging, graphic design, or mission-critical stuff where colors have to be exact.
And they certainly didn't skimp on the audio either.
Oh, not at all. We're talking studio quality. The device is compliant with the most demanding uncompressed formats out there. Dolby True HD, DTS HD Master Audio, ATMOS, DTSX.
The really high-end stuff.
The highest end, up to 7.1 LPCM at 192 kilohertz. That's pristine, multi-channel sound you'd find in a premium cinema, but delivered over IP.
So it's fast, it's high fidelity, it's incredibly scalable, but this thing's more than just a converter, right? It's packed with other features.
Yeah.
How do you actually control a system this big?
Well, the control options have to be comprehensive. So beyond the buttons on the front, you have a full built-in web interface. You've got their VPX management software, and critically, a really robust third-party API.
So that API lets it plug into existing systems.
Exactly. So an integrator can tie it seamlessly into whatever control system the facility already uses.
And we can't forget the USB 2.0 port. It's not just for keyboard and mouse, but it can handle cameras, hard drives, extending that data right alongside the video.
And the encoder itself, the TX unit, has some serious processing tools built right in. Like, it has its own video wall processor for setups up to 8x8.
So that processing is happening at the network edge, not in a central server room.
Precisely. And for those bigger institutional jobs, it's TAA-compliant, which is a must for U.S. government and military projects. Plus, it's super efficient. It runs on power over Ethernet and uses less than 5 watts.
So you don't need to run a separate power line to every single box.
It dramatically simplifies a massive rollout. So, at the end of the day, the VIP-T300-E-RACK2 is just this great example of the AV world converging onto standard IT architecture. You get massive scale, pristine quality, and you keep that ultra-low latency.
Which brings us to our final thought, a provocative one for you to consider. The decoder, the receiver unit, has a powerful scaler built into it. So how does putting that kind of processing, scaling, image rotation right at the endpoint change the whole architecture of these huge display systems?
That's a fundamental shift.
Does it move all that complexity and maybe the cost away from that big central control room and push it out to the network edge? Something to think about for your next huge deployment.